Alright, you don't have to write all of these out, just the third one, because you already know what the diameter of a circle is. It's from one end to the other, okay? So, right off the bat, let me ask you guys a question. How do you compare the diameter to the radius? Twice as much. Yeah. The radius connects the center of the circle to the end, okay? Yesterday was pi day, and I think we briefly talked about the fact if you take the circumference of a circle, divide by its diameter, that gives you pi. Now the third definition is the one I want you to write down. I'm going to draw an example of what a chord is. It connects any 2 points on the circumference of a circle. Alright, so I'll give you a second to copy that. But if a chord connects any 2 points on the circumference, okay? Here's an example. I could go from here to there. You guys see how that's not the diameter, that's not the radius, it's just connecting 2 points? Alright, another example might be from here to over here. That chord is longer than the other one. You could even have a really, really short chord, maybe from like here to there, okay? It just connects any 2 points on the circumference. That's a chord. So when you look at the worksheet, you're going to see, it's going to be a little confusing at first because you're going to see all these lines. But the reality is, all of these are segments. A segment is just a line that connects 2 points. Okay? So a diameter is a segment, a radius is a segment, a chord is a segment. Okay, I'm going to do my best to explain this to you guys. I'm going to pull up a GeoGebra app that someone made. You don't have to write this down, just listen. It's a simple application. First of all, what does the word perpendicular mean? Forms a right angle. Okay? Those two are perpendicular to each other. So a perpendicular bisector, what's bisector mean? Two sections. It cuts it in half, okay? The perpendicular bisector of a chord passes through the center of a circle. So let's just go ahead and take a look at that because that's a lot of wording. See if I can pull this up correctly. Okay, so you guys see this thing moving right here, right? Let me go up to the board and explain this real quick to you guys. Explain that to you guys. So let's do an example. I'm going to do one from the worksheet. Can anybody solve this problem? It's actually very easy.
19 times 8.4.
I like the first thing you said. All right, first of all, let me give you guys a hint. Sometimes in math, they give you stuff you don't need. In this particular problem, you don't need to know that that's 8.4. It's completely irrelevant. So anybody else want to take a shot at what x is?
X is 19.
Okay, good. So let's explain why that's true.
19x divided by 1.
All right, can everybody see that this is the radius of the circle? Why? Because it goes from the middle to the outside. Isn't that the radius?
Yeah.
Okay. But this is also the radius because it goes from the middle to the outside. So a lot of these problems, you don't have to know anything about chords or the bisector theorem. It's just the radius. So that means these two are the same. So therefore x equals 19. Okay, so don't be tricked by unnecessary information, okay? A lot of these are just fill in the blank almost. That's example 1. Let me explain what I just did, okay? If you notice, the first thing I did was I traced 2 equal segments. I'll go back to the step in a second, but basically I traced the radius, okay? So when you label a diagram and you trace the 2 things that are equal, that's going to help you get the right answer. So just trace them with your pencil or whatever. That's going to be your first step. The second step is to set up some kind of equation. Okay, in this particular example, I wrote x equals 19. That's an equation, right? Now, this one's so easy, it solves itself. Sometimes you actually have to do a little bit of algebra. but the third step is equally important. You want to solve for the variable. So let's say you had 2x equals 20 or something. You would divide both sides by 2 and you get x equals 10. So make sure you get these steps copied down somewhere. Okay, so right off the bat, who knows what the answer is for this one?
19.
Okay, so what theorem? How do you know it's 19? Good job. How do you know that x is the same as this over here? Because it's perpendicular and it passes through the center point, so we know that these two segments of the chord are both the same. Okay? So this 22.4 down here for the radius, again, it doesn't matter. Okay? It has nothing to do with solving this problem. So, basically what I'm going to do is follow the same steps. I'm going to trace these two segments, to be the same. So this segment's the same and this segment's the same because of the perpendicular bisector theorem for chords. So therefore, x equals 19. Okay? I promise I'll do one more that's a little bit more advanced than the first two. Alright, so right off the bat, we need to solve for x. I'm going to follow the same steps I just taught you guys. The first step is to trace two equal segments. Now I will tell you this, it needs to include x, okay? There's more than one set of equal segments for each of these. The ones I'm going to trace have to involve x. Any ideas? The radius, yes. So here's the first segment I'm going to trace, right here. Pay attention. Okay? The next segment I'm going to trace that's equal to that is this one. Why? Because they're both the radius. The radius of any circle, no matter where you put it, is the same. So this must be equal to this. Okay? And again, I traced the segment that involves x because I have to solve for x. Okay? Now we want to set up our equation for step 2. Can anybody tell me, raise their hand, what do you think the equation is going to be to solve for x here?
20.4 minus.
Again, these two segments are the same. First of all, let's talk about this segment. How would you write this segment as an expression?
6.
X plus 6. Here's x, here's 6. If you add them together, you get the whole segment. Okay, so first thing I'm going to write is x plus 6. Okay, now it's equal to the other segment. Okay, it's equal to that other segment I traced. What would this segment be? 10.2. Okay, why? Because the whole diameter is 20.4. So this one must be half of that, which is 10.2. Okay, so I've got x plus 6 equals 10.2. Now we can go ahead and solve for x. Only one step needed. What would you do? Subtract 6 from both sides, and you get x equals what? Huh? 4.2. Alright. So I'll let you guys work on this for a little bit, then we'll go over this at the end of the period. If you need help, let me know.